No, it's given. In one you have to find it. No, in one you have to find it. No, you won't find it using formula. You will find it using this. Where do you have I here? Where do you have? In these two equations, where is I? You will find it using the Newton laws. So this will be I alpha. So you will use it using the Newton laws. It's like I will find the mass. You know, now I am asking for the moment of inertia. So not necessarily always the moment of inertia will be found using a formula. They didn't say anything about the radius, they didn't say anything about the mass, so you cannot find it. Sometimes they will say, yes, it's a disk. Oh, yeah, they're different. They explicitly have to say what is rotating. But in this case, they want you find it using the Newton laws. And in the second case, they give, you can see numerically, and you have to find the acceleration. Okay, let's say that now I add one object here, which is the revised adduct machine. Why I said revised? Now the pulley matters. Before, the pulley negligible mass. Now that's it. The pulley matters. So now we have two masses and a pulley. So we have this mass M1 and this mass M2. For instance, I will say that M1 is greater than M2. The question, same. A, find the acceleration. B, find alpha. C, find the tension. But I will say find the tensions. Why? Plural. Because now the tension is not the same on one side and the other. When the pulley matters, the tension are not the same. When the pulley is not an element in the system, we don't care, it's the same, but not now. So, we go back, assuming that it's a disk, or can be a ring, whatever. Let's say now that is a ring. So, in which direction this will be the equation? How many equations we will have? How many equations we will have? Three equations. Two translational, one rotational, or two rotational, one translational. How many translational, how many rotational? Two translational and one rotational. In which direction is moving M1? Down, because M1 is greater than M2. In which direction will be my positive direction? By convention, I said that normally the positive direction is counterclockwise, but you can convent your positive. You can say, my choice is that the direction is in the other side. So this is my direction positive, which is the direction of motion. You can see. So, since the direction of motion is like this, positive, and this now I have to discriminate. This will be 1, correct? And this will be 1. And I need another equation. Which one? Sigma F on what? Equal to what? These are my three equations now. Once we have that, how can we find the algebraical addition? What will be this equation? Oh, by the way, this is going up or down? You see? This requires practice. But it's the same that we did before, so you have to be already an expert. What I added to this, what I am adding to this, in the whole thing, what I am adding to the solution of this? Sigma F, sigma tau equal I alpha. And A equal alpha over R. That is that, and that is in the formula. But require practice, but it's the same, so now you are building up on what you learned before. What will be this equation? This is going down. N1G minus what? minus T1. Now I have T1 and I have T2. This is T2 and this is T1. Equal to what? Second equation. Let's go with the torque 1. I mean, I can leave the torque 1 for the end. Let's go with this one, for instance. What will be this one? In which direction is moving? The second mass. T2 equal? Second equation. And what will be the equation for the poly? Which is sigma tau I alpha. What will be your positive tension, so your positive torque? The one provided by tension 1 or by tension 2? By tension 1 is my positive torque, right? Because it's in the direction of motion. So by definition, what will be? R times what? T1 minus what? R T2 equal to what? One half, but that is from where? That one half is coming from where? One half what? So what is the net torque equal to? I alpha. What is I? If we are saying that this is a disk, what will be I? 1/2 mr squared. Times what? What is alpha? This is the key. You need to remember this. That alpha is A over R. 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 Can you see? So, because 1R I can factor out, will go with the square. And I have R in the denominator, will go with the other R that was left. So, then, tension 1 and tension 1, because this is gone, I have tension positive. Can you see? Yeah. And tension negative, what will happen? And tension 2 and tension 2 negative, what will happen? So what is the leftover in my left side? N1G. N1G is my leftover in the left side. What will be on the right side? N1 plus N2 plus 1/2 M times A. What will be A? N1 divided by N1 plus N2. Oh, by the way, I missed one here. N1G minus N2G minus M2G divided by N1 plus M2 plus 1/2 N. Any question? How do you find the tension 1 and tension 2?